Hi students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Soorya, the chemistry faculty from Infinity Learn. Okay, fine. I hope I'm perfectly audible to all of you. Okay, fine. So welcome to Infinity Learn by Sri Chaitanya. I hope I'm audible. Hi Ashiansh, good evening. We will start our session now. So we have already completed 3 chapters, right? We have already completed about 2 chapters of the NCERT solution. So here we are moving with the next chapter, metals and non-metals. We will be discussing about the NCERT exercise, right? I have taken only few questions, which I feel very difficulty from the chapter. So we can start our questions here. Hi Arush, good evening. So those who are watching the live, just mark your attendance here so that I can understand. Okay, fine. Okay, here is the first question from the chapter, metals and non-metals. Read the question carefully and just let me know what is the answer for this question. Which of the following methods is suitable for preventing an iron frying pan from rusting? Okay, options are provided here: applying grease, applying paint, applying a coating of zinc, and all of these. Okay, Ashanshi is giving me the answer as option D. What about others? Okay, let's see what is the answer. Option C is the correct answer, right? So these are the very important methods for the prevention of rusting of iron. But our question, what is our question? In our question, they are asking about the prevention of rusting of iron frying pan, right? Iron frying pan, which means we are using the cooking vessels, right? So if you are applying grease or paint, is it possible? It will be very difficult, right? It will become poisonous. So prevention of rusting method are the applying grease. So whenever your answer for the any question, read the question carefully. Ashansh, I hope you understand. So if they are asking about the prevention of rusting of iron, you can give these options like applying grease, applying paint, and applying coating of zinc. These are fine, right? But especially if they are asking for the cooking vessels, if you are applying for the iron frying pan, we can use the coating of zinc, which will prevent the rusting of iron. I hope you understand. I'm repeating again, read the question carefully when you are answering for the questions. Fine. So here is our next question. Okay. Read the question carefully. This is about the properties of metals and non-metals. An element reacts with oxygen to give a compound with a high melting point. This compound is also soluble in water. The element is likely to be. Okay, is there any issue in the class? I hope I'm audible and visible to everyone. Okay, fine. So what will be the answer for this question? So I hope you understand the meaning of the question. An element reacts with oxygen to give a compound with a high melting point. So we know that whenever any element which is reacting with oxygen, that will be forming the corresponding oxide, right? So this will be one of the oxide of any of the element given here. And this element, this oxide will be having a high melting point, right? High melting point. Then after treating with water, right, this compound is also soluble in water. So we need to identify the element, whether it is calcium, carbon, silicon or iron. Choose the appropriate answer. Main point you have to keep in mind that it is about the oxide which is having the high melting point as well as they are soluble in water. So I hope you got the answer as option A, that is calcium, right? So calcium will be combined with oxygen to form calcium oxide. Then this will be having the high melting point as compared to the oxides of all other elements like carbon, silicon and iron, right? So this will be having high melting point. Then this is again soluble in water, right? This is again soluble in water. If you are treating with water, that will be forming the calcium hydroxide. I hope you understand. Maybe some of you have doubt in the case of carbon. We know that carbon will be reacting with oxygen to form carbon dioxide. This is again soluble in water, right? But in the case of combined with the melting point, we can say that carbon dioxide will be having very less melting point as compared to calcium oxide. Is that clear? Now here we are moving to the next question. Food cans are coated with tin and not with zinc because what will be the reason behind that? So this is the question based on the reactivity series of metals. We have already studied the reactivity series, right? So just think about the reactivity between tin and zinc, whether it is higher or lesser as compared to them. So what will be the answer? Just let me know in the comments. So options are provided here. Zinc is costlier than tin. Zinc has a higher melting point than tin. And zinc is more reactive than tin. And zinc is less reactive than tin. Just think about the perspective of reactivity of tin and zinc. Okay, let's see what is the answer. So yes, option C is the correct answer. Ashyan, you are correct. So we know that, right? I will write down the reactivity series over here. So these are the reactivity series, right? As you are comparing the reactivity of zinc and tin, you can see zinc is more reactive than tin, right? So zinc is more reactive than tin. That will mean option C will be our correct answer. I hope you have an idea about the reactivity over here. So as moving from potassium to gold, you can see reactivity decreases. Arush, I think you have any network issues. So here option C is the correct answer. I hope you understand. Now we are moving to the next question. Read the question carefully. Pratyush took sulfur powder on a spatula and heated it. He collected the gas evolved by inverting a test tube over it as shown. Okay, figure is not given here. So what will be the action of gas on dry litmus paper, moist litmus paper, and write a balanced chemical equation for the reaction taking place. So you can see a proper image in your textbook. Just like they are taking the sulfur powder on a spatula and heated it and collected the gas that is produced over there and inverting it into the test tube over it. What will be the observation? What is the gas evolved over there? Then what will be the reaction when it is treating with the dry litmus paper as well as the moist litmus paper? And write down the chemical reaction over there. So what will be the answer for the first question? What will be the action of gas? Which gas is produced over here? Whenever you are heat the sulfur powder. Okay, I hope you got the answer. So let's see here, right? When sulfur powder is burnt in air, sulfur dioxide is forming, right? Sulfur dioxide is forming. Then, whenever the sulfur dioxide is treating with a dry litmus paper, it does not have any effect on the dry litmus paper. I hope you understand. Then, what about the case of moist litmus paper? That will be containing the water molecule, right? So that will react with, this sulfur dioxide will be reacting with water to form the sulfurous acid. Sulfurous acid that is acidic in nature, so that will turn the blue litmus to red. We have discussed in the case of acid, base and salt, litmus paper change red, blue to red. Then what is the reaction happening here? Arush, what is the confusion here? This is sulfur dioxide, right? Sulfur dioxide. So here it is acidic in nature, so that will be reacting with water to form the sulfurous acid, which is acidic in nature, so that they are turning the blue litmus to red litmus, not red to blue, right? So this is a reaction given here. Sulfur react with oxygen to form sulfur dioxide SO2. Then this sulfur dioxide will react with moisture or the water content in the litmus paper to form sulfurous acid with chemical formula H2SO3. Is there any doubt? Okay, I hope it is clear. Now here is the next question. What are amphoteric oxides? Give two examples of amphoteric oxides. So we have discussed in the case of metals and non-metals, what is the reaction with oxygen, right? So metal will be reacting with oxygen to form metal oxides. They are acidic in nature, they are in basic in nature, and non-metals are react with oxygen to form non-metal oxide. They are acidic in nature, right? So what do you mean by the amphoteric oxide? Give two examples for the amphoteric oxides. So can you please define what you mean by amphoteric oxides? What is their nature? Yes, that will react with both acid as well as bases, right? So we can define the amphoteric oxides that react with both acids and bases to form salt and water, corresponding salt and water, and they are known as the amphoteric oxide. What about the examples? Most common example is the aluminum oxide, Al2O3. Yes, Al2O3 xenon is also present. Then lead oxide is also present, right? So these are the examples of amphoteric oxides. You can expect this type of question for the 2 marks question. Clear? Then we have already studied in the case of periodic table, right? Extreme right side and left side. Whenever metal are combined with oxygen, what is the nature of metal oxide? Acidic or basic? Metal oxides. So the metal oxides are basic in nature and non-metal oxides are acidic in nature. So you must have a proper idea about the examples of acidic oxides, basic oxides and the amphoteric oxides. Clear? Now here is the next question. Name two metals which will displace hydrogen from dilute acids and two metals which will not. I hope you understand the question. We need to give the name for two elements that will displace the hydrogen from dilute acids, which means that name two metals which are highly reactive than hydrogen and name two other elements which are less reactive than hydrogen. So it is completely upon to you. You can give any of the metals which will displace the hydrogen from dilute acids depending upon the reactivity series. Yes, one of the examples is potassium and sodium, right? So I have given the answer as zinc and magnesium. I am repeating again. You can use any of the metals which is above the hydrogen in the metal series or the reactivity series, right? So zinc and magnesium are the two metals which will displace hydrogen from dilute acids as they are very reactive metals, right? So you can give me the answer as potassium, sodium, magnesium. So these are the higher reactive metals than hydrogen, right? So these can easily displace hydrogen from the dilute acids, while these elements are the less reactive metals. I mean, these are the less reactive metals than hydrogen, so that does not displace hydrogen from the dilute acids. So we can say either zinc or magnesium or any of these metals like potassium, sodium, magnesium, aluminum, zinc, iron, tin and lead, right? Then what about the other two metals which will not give hydrogen? That is about either copper, silver or gold. Is that clear? Okay, fine. Okay. Okay, Ashish, we are going to discuss about the aqua regia. There is a question in the NCERT textbook. Let's discuss there. Okay. So this is our next question. I have given the answer already there. State two ways to prevent the rusting of iron. You can give any two answers for the prevention of rusting of iron. So we have studied, right? First is the galvanization, painting and applying oil or grease, right? So iron can be prevented from rusting by coating the surface of the iron with rust-proof paints, or simply it will be painting, right? Then what about the next method? By applying oil grease on the surface of iron objects, as it will prevent the iron surface to get in contact with air consisting of moisture. No need to worry. We know that what you mean by rusting, right? What you mean by rusting or the what do you mean by the rusting or the corrosion, right? Whenever the iron substances come in contact with the moisture or the other substance in the surface, that will get corroded, right? So in order to prevent the corrosion, we will be applying oil or grease. So one method is the painting, another one is the applying oil or grease, and galvanization is also possible, right? We are applying a zinc coating over there, just like we have used in the frying pans, right? So many methods we have already studied for the prevention of corrosion or the rusting of iron. You can write any two methods for the prevention of rusting of iron. I hope you understand. Okay, here is our next question. What type of oxides are formed when non-metals combine with oxygen? What type of oxides are formed when non-metals combine with oxygen? Okay. Arush, you are almost correct, right? So here it is already given when non-metals combine with the oxygen, they will form either acidic or neutral oxides. Generally, they will be forming the acidic oxides. So some of the exceptional cases are also there. They will be forming neutral oxide also. Most common example for the acidic oxide is the N2O5, N2O3 or Cl2O7, right? I mean oxide of the chlorine. Then neutral oxide is the carbon monoxide. I hope you understand. We have already discussed the reaction of oxygen with the metals and non-metals. Here it is about the non-metals. Generally, they will be forming the acidic oxide. Common example is the N2O5 and N2O3, and Cl2O7 is also present. Sometimes they will be forming neutral oxides also. One of the example is the carbon monoxide. Is that clear? Okay, I hope it is clear. Then this is the reasoning question. Two sub-questions are given here. Give reasons platinum, gold and silver are used to make jewelry. Okay, they are lustrous in nature, right? Lustrous means they are shining. As said, we are using platinum, gold and silver are used for making jewelry. One more point is there, they are inert metals, right? They are inert metals. They are very less reactive, hence they are not affected by air, water or moist chemicals. Clear? So the one of the properties, yes, they are less reactive. Yes, one of the properties is their lustrous nature, that will be given the shiny in the jewelries, right? So they are lot of luster and they are malleable and ductile in nature. What do you mean by malleable? We can draw them into the thin sheets, right? Thin sheets as well as the ductile means thin wires, right? So Pida, what is the confusion here? Okay, I hope it is clear, right? So they were asking about the platinum, gold and silver used for making jewelry. So one of the main important properties about the properties of metal. This one, right? Okay. Why? Malleable and ductile properties are already used. That's why we can make into different shapes, right, for the jewelries. If you want to make the chain, that will be drawn into thin wires because of the ductile property. If you want to make the viscous type of gold packets, we need to use the malleable property. Arush, is that clear? Okay, fine. Then what about the next question? I mean, sodium, potassium and lithium are stored under oil. So this is again about the reactivity series, right? Reactivity series of the metal. So ductile means it is the wire. We need to convert it into the thin wires, and malleable means that will be converted into thick sheets. I mean thin sheets or thick sheets. Anuj, if I start speaking in Hindi, it will be much more difficult for you to understand. Okay, what about the second question? Yes, sodium, potassium and lithium readily reacts with water to produce a lot of heat. We have studied, right? These are the highly reactive metals. So as a result, the hydrogen involved in the reaction results in fire. So these are explosive in nature, right? These are explosive in nature. That's why we are not keeping it in the water. We will be generally using the, store this in the under oil, right? So in order to prevent the contact of these metals with water, hence these metals are stored under oil. I hope you understand. This is about the highly reactivity of the sodium, potassium and lithium elements. Okay, fine. Now here is the next question. Okay, this is again about the corrosion of copper. You must have seen tarnished copper vessels being cleaned with lemon or tamarind juice. Explain why these source substances are effective in cleaning the vessels. Think about the corrosion perspective, what you mean by tarnishing of copper, how we can prevent the tarnishing of copper. So what will be the answer? Anyone? Please respond. They contain acids and while tarnished it form basic copper carbonate, right? So it's almost right. So we can give a proper answer for that. So we know that, right? In the case of tarnished copper, tarnished copper vessel means this tarnishing is due to the presence of basic copper carbonate, right? Basic copper carbonate. And being cleaned with lemon or tamarind, they will be contain the acidic substance. In the case of lemon, that will be citric acid. In the case of tamarind, that will be tartaric acid, right? So because of these source substance contains acids which dissolve the coating of copper oxide or the basic copper carbonate. I hope you understand. So what is the reason behind the? Yes, Yadi, you are almost correct. Yes. So tarnishing means that tarnishing is responsible by the basic copper carbonate or the copper oxide. So we need to neutralize the basic substance in the case of tarnishing of copper, right? So we are adding any of the substance that will be containing acidic. So we are commonly using lemon juice or the, yes, lemon or lemon juice that will be containing the citric acid, right? That will be containing the citric acid that will be dissolves the oxide layer over there. Then what about this tamarind that is containing tartaric acid? Clear? Hence, they are very effective in cleaning tarnished copper vessels. You can try in your home. Now we are moving to the next question. This is very easy question. Differentiate between metal and non-metal on the basis of their chemical properties. So we have already studied many chemical properties based on metals and non-metals, right? Ashian, tarnishing means it is the method of corrosion, as we have already discussed about the case of rusting of iron, right? So in the case of copper vessels, that will be come in contact with the moisture or the air substance to form a blue color surface over the copper substances, right? So that blue color over the tarnished copper is due to the basic copper carbonate. Maybe you have seen in the case of images about the Statue of Liberty, right? They have that is made up of the copper. After some time, that will be changes to blue color or the bluish green color, right? This is because of the tarnishing of copper, because of the presence of basic copper carbonate. This is again another example for the corrosion. Okay, what about the answer for this question? Okay, these are some of the differentiation I have given for the metals and non-metals. Yes, metals are strong reducing agent while non-metals are strong oxidizing agent and they react with acids. Okay, most of you are giving me the answers that are almost correct. So let's see here, right? When heated with oxygen, they form ionic oxides, right? They will form ionic oxides, which are basic in nature. Clear? Then, if they are basic in nature, that will turn the red litmus to blue, right? Red litmus to blue. Then, they are electropositive in nature, right? They will easily remove the electrons, lose electrons readily and form the positive ions. So, they are cations. Metals are cations, right? Then, metals are lustrous in nature. You can give any other properties depending upon the metals. I have given only very less chemical properties over here. Similarly, in the case of non-metals, right? They will be heated with oxygen. They form covalent oxides by the sharing of electrons, right? Then they are acidic in nature, turn blue litmus to red, right? Yes, blue litmus to red. Then they are electronegative in nature, right? They will be accepting electrons or gaining electrons to form the anions. Then they are non-lustrous in nature. Exception is there for the case of graphite, an allotrope of carbon, right? Carbon is already an non-metal, but they are lustrous in nature. You can see the nib of pencils. Is that clear? Yes, this is about the physical property, right? Yes, this is about the physical property. Okay, our question is based on the chemical properties, right? Okay, you can give the chemical properties as well. Okay, now we are moving to the next question. So here we are going to discuss about the role of aqua regia. Okay, I have just given the differentiation between the metals and non-metals just for a revision. You can give the answer based on the chemical properties only. Arish, I hope you understand. So here is a long paragraph question. Read the question carefully. A man went door to door posing as a goldsmith. He promised to bring back the glitter of old and dull gold ornaments. As unsuspecting lady gave a set of gold bangles to him, which dipped in a particular solution. The bangles sparkled like new, but their weight was reduced drastically. The lady was upset, but after a futile argument, the man beat a hasty retreat. Can you play the detective to find out the nature of the solution he had used? The question is little bit lengthy, and the meaning of the question is that whenever any solution containing gold solution is dipped in some other solution, they will become very more glittering, right? They will become very more glittering, but their mass will be reduces. What will be the reason behind that, or which solution was used by the man to dissolve these gold substances? Okay, some parts of gold got dissolved in the solution, that is royal water, aqua regia, the weight got reduced. Yes, correct. So this solution is known as the aqua regia, or commonly known as the royal water, right? Royal water means it can easily dissolve the gold substances, right? So it is a mixture of concentrated hydrochloric acid and the concentrated nitric acid in the ratio of 3:1. I think some of you have asked me about the aqua regia, right? So aqua regia is the solution of 1:3% of the concentrated nitric acid and concentrated hydrochloric acid, right? So we can written here, if you are taking HCl is to HNO3 in a 3:1 ratio, right? 3:1 ratio, you will be getting the royal water or the aqua regia that will be easily dissolves the gold substance, like not only gold substance, like all the noble metals. When upper layer of dull gold ornament is dissolved, they lost their weight. Clear? Is there any doubt? So don't get confused over about the ratio over here. If you are taking 1 liter, if you are taking the one ratio of 1 liter of the HCl, you will be taking the triple 3 liters of the HNO3 and so on, right? 3:1 ratio. If you are taking 3 moles of, let's say in terms of moles, if you are taking 3 moles of HCl, you should take the 1 mole of HNO3. It depends on if you are taking HCl. HCl is to HNO3 will be 3:1. HNO3 is to HCl will be 1:3, right? Is that clear? It's not that much corrosive. It will dissolve some of the gold amounts. That way their weight will be reduced. Clear? I'm repeating again. This ratio will be, remember, right? HCl will be 3, HNO3 will be 1, or reverse. If you're taking HNO3 1, HCl will be 3. So on. Almost similar, right? Here is the next question. Give reasons why copper is used to make hot water tanks and not steel. This is again based on the reactivity of copper. Copper is used to make hot water tanks, right? And not steel. So this is the reason, right? Reactivity of the copper. Copper does not react with either water or the steam. Okay. Yes, Siddhi, you are correct, and Arush is almost correct. So we need to give the answer in perspective of the reactivity series, right? So copper is used to make hot water tanks and not steel. We know that steel is an alloy of iron, right? So we will be comparing the reactivity of, reaction of iron and copper with steam or water. So the copper does not react with either water or steam, right? Either water or steam, especially for the cold water and steam, right? Cold water and steam. Then what about the case of iron? That will be react with steam and corrode the tank. Is that clear? So while discussing about the chemical reaction of, reaction of the metals and non-metals with the water, I have already mentioned, is completely depend upon the reactivity series, right? If you have the highly reactive metals, they will easily react with the cold water. Then for magnesium, they will be reacting with the hot water, right? Hot water and steam, right? Hot water, then and some other elements, they will not react with either cold water, hot water or steam. Is that clear? It's about the reactivity series. So I have clearly mentioned in the concept classes, the recorded session there. So those who are not watched the recorded session, just make sure that you have already watched the recorded session. I have already mentioned the chemical properties of the metals and non-metals over there, especially for their reaction with water. Okay, that was the last question. I hope you understand. I have taken, in the case of NCERT, there are already 16 questions are there in the exercises. So I have taken only very few questions that I got very difficult. And those remaining questions are there. You can try by yourself to solve those questions. If you are facing any difficulty, just let me know. We will discuss in the next class. Then, if you have any doubt, you can ask. Otherwise, we can wind up the session for today. So far, we have already completed the 3 chapters. Right? We have already completed the NCERT solutions for the first chapter, chemical reactions and equation. Then acid, base, and salt. Right? Then we have completed the metals and non-metals also. In the upcoming class, maybe on Friday, I will be taking the next chapter, carbon and its compounds for their NCERT solutions. So before coming to the session, just revise the topics you have completed in the concept classes about the very important concepts in the case of carbon and its compounds. Okay, do you have any doubt? You can ask, otherwise we can end the session for today. Okay, Yadi, thanks for the compliments. So I hope you guys enjoy the session. If you really like the session, hit the like button and share this particular session to your friends also. That will be really helpful for them also. Then subscribe our channel for more updates, right? Infinity Learn 9 and 10 telegrams. And you need to join for the telegram channel also, Infinity Learn 9 and 10 telegram channel. So after all the session, you will be getting the session PDF over there. I hope you have already joined the telegram channel. Okay, then that's all about from my side for today. See you in the next class. Bye-bye.